Good morning everybody. Today I will start topic on priming, foot valve, suction, delivery, total head and some other topics also there with some calculations. So, previous lectures we have discussed about centrifugal pump, positive displacement pump. We have seen the difference using our characteristic curves, like centrifugal pump will have HQ curve like this, but positive displacement pump will have vertical line, almost vertical. Okay. Uh, so, positive displacement pump can deliver very high amount of pressure or head, while centrifugal pump will have limited head. Okay. Now, we have seen the NPSH requirement. Centrifugal pump will have higher NPSH or net positive suction head requirement. So, net positive suction head two type, one will be net positive suction head available, one will be net positive suction head required. Required will be given by company, but available you have to make it available. So, whenever talking about NPSH available, so this available, sometimes we put some suffix a, or we many way we put the notation NPSH a or small a. So does not matter if we are writing NPSH available. Okay. So NPSH available depends on your inlet suction pipe. If this is pump, this suction pipe length, pipe diameter, length, diameter, fluid vapor pressure. If fluid vapor pressure is very low, like if you are increasing temperature, vapor pressure will be changing. So in that case also NPSH will be getting affected. Very long pipe, NPSH will get affected. Diameter of the pipe, friction will be increasing, so NPSH will get affected. If pipe friction is very high, or if you have sharp bends, maybe many bends like this in pipe, okay, sharp bends, then again your NPSH will be available will be lower. Okay. And if you are changing temperature, again temperature will be changing, vapor pressure, that will be affecting. The other parameters may be like if you have some fittings here, maybe some joining of two pipes, so there will be again pressure drop or pressure loss. If entry is not designed properly, sharp entry is there or narrow entry is there, so in that case also there will be lots of pressure drop. So lots of pressure drop means actually it will be reducing your NPSH available. If company is asking keep NPSH 5 meter, NPSH required 5 meter, then your available must be more than 5 meter, not equal to. Okay. Whenever if you are maintaining equal to, whenever running pump, actually NPSH availability going down because fluid will be flowing. So that time because of pipe friction and other losses, your NPSH availability going down. So you must maintain some higher amount of NPSH available than required. Okay. So NPSH available or NPSH required when you are talking about, so you should remember one cavitation parameter sigma equals P minus PV divided by half rho V square. Okay. And sigma, okay, P means pressure, PV is vapor pressure, rho V means velocity kinetic head. Okay. Now if sigma less than 0, so cavitation will be occurring. So and cavitation is linked with NPSH, means inlet pressure is you are maintaining low, so vapor will be created or small bubbles will be created when pump is running. When pump is running, the small bubble created, now pump will be delivering at high pressure, so bubble will be collapsing again. When creating and collapsing happening, so lots of metal particle will get removed, noise will be coming, vibration will be happening, so whole pump can fail, or after certain operation pump will be eroded completely. So cavitation is having negative impact in your fluid mechanics systems. For example, your valve, your choke, your wellhead, your pump, everywhere if cavitation probability is there, you have to remove that probability. So how to change it? You have to check specific instrument. For example, diffuser is there where low pressure is happening. Is it because of fluid viscosity, fluid temperature, or any fluid very high velocity, or whatever points I raised here, length, diameter, vapor pressure, whether those creating low pressure. If low pressure is getting created, then you have to redesign the whole system maybe, or you have to increase maybe inlet pressure, somewhere some pressure is there. So that way you can avoid cavitation. Okay. So cavitation is having negative impact on your fluid mechanics systems, piping systems, pumping systems, your valve systems, your choke systems. Okay. Priming. Now priming. The centrifugal pump, when it is running, actually you are creating, my eye is there, impellers like this. You have seen yesterday, I have shown you one actual impeller. When it is rotating at very high speed, so fluid will be sucked from eye and it will be exiting. Okay. from this channel. These are the impeller blades. These are blades. These are blades. Okay. So what is happening? First, near I, fluid particle will get accelerated. When it is going out towards exit, it will be getting further accelerated, and fluid particle will go out. Okay. Now this is having one volute casing casing. Okay, and pipe will be coming like this. Okay. Now if pipe is not filled with liquid, what will happen? So impeller will try to push fluid out, and fluid means liquid particle, high density particle. So high density particle will be touching each other, and it will be sucking lower fluid from the suction pipe. Now if there is no liquid, so if only gas particles are there or air particles are there, air particle density is very low. So it will not create enough momentum. Okay, when it is not creating enough momentum, it will not be able to sucking the fluid. Okay, so that will be a problem. So during starting stage, actually you have to fill the pump with liquid. So that is called priming. Okay, fill pump before starting. Okay, so before pump you have to fill, otherwise it will not start delivering fluid. Okay, once started delivery, after that priming there is no meaning. Okay, only before starting you have to fill the system. Okay, now foot valve. What is foot valve term is there? So in many cases, many like say you have drilling mud, and you have to pump out the water. Okay, so in that case you fill the pump, but when you are filling from top, there will be some hole here actually on the top. Okay, so you are filling, but pump water will be going out. So there will be one foot valve actually like this. Okay, one way valve. Okay, when you are filling, valve will be closing and your filling will be occurring. Okay, so and when pump will be starting, so valve will be open the path, it will be like this. So fluid will be entering, and this is lots of pores will be there. Okay, so fluid will be going through this, and it will going through this. Okay, and when started pumping, the valve will be opening path and it will be delivering fluid. But when if you switch off the pump, valve will be closing the path, so all the suction pipe will be filled with liquid. So when next time you are starting, it will help actually. Otherwise, if you don't have that valve, foot valve, what will happen? You fill from top, it will be drained out. Okay, then your pump starting will be a problem. So priming will not occur. So if you want to do proper priming, then you should have one foot valve actually. Okay. So suction means this side is suction because sucking fluid. This is suction side. Okay, and delivery side means fluid is delivering outside. Total head. Okay, so total head is like this. Like I have pump here. I am not drawing any pump. I am just writing pump. Okay, so pump is sucking fluid from my tank. Okay, now it is delivering to a level of here. Okay, so this is my suction side, pump center line to water level. Okay, suction head or suction side, you can say suction. This is delivery, and pump center line is like this. Pump center line like this here. Okay, so pump center line is here. Here also I have pump center line. I am not drawing exact pump. I am just box I have drawn. Okay, now this side, the pressure is called suction head. Okay, because near positive suction head, I told the term, the suction head. So this side pressure is suction. So when you are calculating suction NPTEL, it is not related to delivery, it is related to suction. Okay, so that's why suction word is there, net positive suction head, and this is delivery side. So this is delivery. So HS maybe you can put, I can put HD delivery. Okay, so total head HS plus HD. Okay, H equals HS plus HD, but there will be some losses, just ignore for the time being. So pump, when you are giving electricity, so pump will be sucking plus delivering. So total energy, suction side how much energy required, delivery side how much energy required. So total energy is HD. Okay, if you have friction loss and other losses, that also you have to include. Okay, so power in watt, what will be P equals rho Q H G by eta. Eta is efficiency, and units are like this. Rho means meter cube per volume per meter cube, kg per meter cube, kg per meter cube. Q means meter cube per second, and H means your meter head, how much head is delivering. G already you know, 9.81 meter per second square. Okay. P in HP, if I see P in horsepower, okay, horsepower, then rho Q H 3960 eta. So this term will be coming. Okay. Overall efficiency, I already told that pump hydraulic efficiency will be there and motor efficiency will be there. So if you multiply these two, it will be calling overall efficiency. So eta pump or hydraulic efficiency into eta motor efficiency. Okay, this is overall efficiency, electrical to water delivery or liquid delivery. And many times I think I am writing water, so it can be any liquid. So it may be your oil, you know, oil filled application, or normal water oil fill means you are handling water also some cases. So that can be water also. Okay, high pressure, low pressure, anytime, but you have to check vapor pressure whether it is creating cavitation or not. Okay, so you design a certain pump for your water application and you want to apply for your, let's say, petrol pumping. Petrol you have and you pump to pump into system. So petrol will be evaporating quickly. So in that case, it will be quickly giving that vapor and cavitation, right? So that will be detrimental. That will have a detrimental effect. So in that case, you have to check how much NPC is required, how much you have. Accordingly, you can select a pump. Head calculation. So now you have seen centrifugal pump. It is having one impeller, one casing, and it is having a suction pipe, one delivery pipe. Okay, before starting you must do priming. So during priming, your suction valve or foot valve will be closing the path, and when pump is running, it will be automatically opening and it will be delivering fluid. Okay, now it can be have radial impeller or axial impeller or mixed flow impeller. So normally we will be using radial or mixed flow impeller. Axial impeller normally we do not use. Now how to calculate head? Now if you have very low head, so in that case you can use multiple stages. For example, electric submersible pump, I have shown you already. So you have multiple stages, 1, 2, 3, 4, and you can develop very high amount of head. Okay, but if you are let's say if you want to replace sucker rod pump and using a ESP system, randomly you cannot do, because you have to check other properties also, whether wellbore is capable of taking that pump, or you have electrical input facilities, and many other parameters are there. Yeah, I have another course, artificial lifting system, in NPTEL. So if you are interested, you can go through that course. Video lectures, I think it should be available freely in YouTube, so you can watch that also. The details of pump, different types of pumps, pump fundamentals also explained in that course. So here in one lecture means 1 week lecture, I'll be giving only a few things, not details. But if you go through that NPTEL artificial lift lecture, you will find more details in that about pumping systems. So overall efficiency first. Overall efficiency already you have seen, eta mechanical motor into eta hydraulic or pump. Okay, so we can write in this way also. Water power, water means how much water delivery. Okay, water power divided by shaft of power. Okay, so rho, okay, already this formula is given. So impeller diameter and head relationship, head equals eta u square by 2g, eta hydraulic efficiency or pump efficiency. Okay, eta pump efficiency. U is impeller speed, tip speed, you can say tip speed. Okay, and how to calculate the tip speed? Omega into r. Omega angular velocity, okay, angular velocity. So how to get omega? 2n pi by 60, okay, and what is n? N equals rpm. So revolution per minute, it will be given in the problem, or you may be measuring also using tachometer. So speed measuring instrument is called tachometer, okay. A fluid measuring instrument called flow meter. Pressure measuring normally barometer or pressure sensor, we can use the term. So you should remember the names, okay. So measuring instrument, tachometer, speed sensor, many time in bike they say speedometer also, but normally in laboratory I use tachometer, okay. One light sensor will be there, it will be checking the speed, how much speed we are getting. And flow meter, you are getting fluid flow rate, okay. Barometer, you can get pressure, or pressure sensor will have, okay. What are the flow meter measuring instrument use? So n is rpm, we are using tachometer, we can measure this one, okay. Now what other parameters are there in the formula? Formula will have g. G value already you know, 9.81 meter per second square. If you are using different types of unit, G value will be different, okay. So normally centrifugal pump efficiency will be 60-70%, okay. So if I do not give any value, and if I ask just put any guess value, so just take any guess value between 60 and 70, okay. But if I am taking online exam, in that case I will give exact value. Otherwise if I give class exam, so in that case I will ask, okay, guess any value and do. So you should have proper guess, means within 60-70 you are guessing, this is okay, okay. You should not say like a 30% or 90% or 100%, okay. Except I specify take 100% efficiency. And centrifugal pump, I said like stage, number of stage, right, of stages. Let us say one stage is having 10-meter head. So 10 stages, 10 into 10, 100, okay. So how to calculate? Okay, so let us say one simple problem. A pump delivers water to 100 meter. 100 meter, one building height less 100 meter, it is delivering, okay. And efficiency 70%, okay. The impeller diameter 6 inch, 6 inch impeller diameter. Ignore other losses means piping losses and other losses, ignore. Then dia of impeller, okay. Ignore other losses, ignore other losses. So calculate number of stages, and rpm is given, let us say 1400, okay, rpm. So how will you do? First you have to use this formula, okay. H equals eta, I have given percentage, I have given 70%, so 0.7 u. U how to calculate? U have to calculate omega into r, right, fine. Then 0.7 into omega means 2n pi by 60 into r whole square divided by 2g, okay. So from here you get 0.7 2g into 2 into n means 1400 into r value is your inch is given, okay. So here you have to convert into meter, okay. So 6 inch means 150 millimeter approximately, okay, approximately 150 millimeter. So 150 divided 1000, then divided by 60 whole square, okay. So some value will be coming. Are you calculating, anyone? So can you give value there? Hmm? 5 meters. No, H, how much you are getting? Because step by step it is shown. 78 meter H. 17. Okay, so from there you are getting H 17, about 17 meter. So number of stages equals 100 divided by 17. So about 6 stages. Correct. Okay. Now we'll move towards positive displacement pump. We have discussed now centrifugal pump. Now I said that there are basically two types of pumps: centrifugal and positive displacement, or basically reciprocating type. So positive displacement may have different types. For example, diaphragm pump, reciprocating type, progressive cavity pump, screw pump, vane pump. Many other different types also possible, or mix up of all these things. So a few slides I will discuss on basically reciprocating type pump, because if I want to discuss everything, it will be whole course. So because I have to limit within a few minutes. So this one I will try to discuss. Reciprocating pump, actually you have seen in your oil and gas sucker rod pump. If you see any oil and gas related picture, you will be seeing this beam pump or sucker rod pump, the same thing actually, reciprocating pump. So one piston will be reciprocating and you will get a fluid flow, and that will be giving very high flow rate, a very high head but low flow rate. Okay. So positive displacement or reciprocating type pump, there are differences like simplex, duplex or double throw pump, triplex or triple or 3 throw pump, 4 cylinder, 5 cylinder, single acting, double acting. So many types of reciprocating pump also available. Again, I am not discussing everything. Maybe I will try to teach only the single acting and double acting part. And if you want to know further about different types of positive displacement pump and simplex, duplex, everything, then you have to go to my NPTEL lecture, artificial lift. NPTEL lectures, NPTEL course, artificial lift. There I have given all details of different types of pumps used for artificial subsurface application, but the fundamental part you can study there. So if I said diaphragm pump means like I will have one diaphragm, and if I have one piston, this one soft material, this is diaphragm. Okay, and if I have valve here, one valve going out, one valve in, so continuously if you push up and down, so fluid will be getting delivered. So that is called diaphragm pump. It has having different application in chemical industry. So our lungs also one diaphragm pump actually. You see, you are pumping it, right? You are putting in, putting out. Okay, so we don't have any valve here, but that is also one diaphragm actually, softer material. Okay, you are not mixing with other fluid. Reciprocating pump, roadside cycle pumper, right? Where electricity not there, so people are pumping cycles. This is reciprocating pump. You are using same thing actually for your sucker rod pumping systems. Okay. Progressive cavity pump, I have already shown you one model. Progressive cavity pump also single screw pump, so that is also used for very high viscosity fluid pumping systems. The screw pump, okay, PCP also a screw pump. So this is single screw, but you can create multiple screw, double screw also. Vane pump, many time it is being used for refrigeration application, for your household refrigeration. Normally they will be using vane pump. Scroll pump is there, vane pump, many other types of pumps will be available, okay, for positive displacement side. Again, I said reciprocating type also having different types. So among these, single acting, double acting, there are two types.